Guys, we need to talk about Apollo. You have to understand that this whole thing was a hoax. I'm saying that as somebody who's investigated the whole thing. I've studied history at university. I'm not saying that my degree is primarily in history. Part of my degree was history. I did quite well at it. Probably the strongest part of my degree, TBH, although I only took it to second year. But still, I know what evidence is, and I've examined the historic record. And unusually, probably for a historian, I'm quite well versed in the science. And the particular point is thermodynamics. So the simple fact is that people are having a hard time getting their head around is that when you go outside the very thin protective atmosphere of the Earth's atmosphere, did I say that right? The protective envelope of the Earth's atmosphere, you're into the heat if you're going towards the sun. Obviously, if you're going out from the Earth's shadow, you've got a bit of protection there. And like, they had to counter that with something, right? So they countered it with this idea of the interstellar medium. And they're talking about when you go a long way away from the sun. They're not talking about when they're talking the interstellar medium, they're talking about the gap in between the galaxies, the spaces in between the galaxies where the radiation from stars, thermal radiation, all radiation is kind of thermal radiation in a very real sense. But, when you're out there, not that I've been out there, none of us have, people haven't been out there. There's a probe that's left the solar system. That's a long way from the interstellar medium, in fact, I would say. But, the true interstellar medium is in between the galaxies. So, Voyager 1 and 2 are a long way from that. But the point is, even if you, say, go out in the direction of the Earth's shadow and you're covered, they'd like you to believe, they have for a long time, they've put forward the proposition, and this is the actual scientist, like Collins talks about this, the artist, and he says, yeah, one side of a spanner that's floating around in space, the sunny side is going to be 200 degrees Fahrenheit, 200 degrees centigrade, and the cold side's going to be absolute zero. And, any mechanic will tell you that spanner will explode. That doesn't happen. If one side of the spanner is hot, the heat conducts right through. There's another thing that they try to put about for years, that conduction doesn't work in space because there are no molecules. Well, astronauts have got molecules in, so spaceships and so spanners. And if one side of the spaceship gets hot, that thermal, and you've got to use this term very correctly, between your heat and thermal energy. So the sun heats up, and thermodynamic systems, these are all terms that you've got to use carefully, correctly, accurately. But we're doing it here, and we're like it in a minefield because, you use the wrong term and people pounce on it. And, I'm ready to do some pouncing myself. I mean, most of the stuff that I see, anybody talking about the Apollo missions, and they're explaining how the scientists managed, how the crew managed to survive the heat, there's a lot of pounceable stuff that comes up. And basically, it's one of those ones, you evaluate, you take the evidence. Look, it's hot out there. It's just hot. Once you get in the sunshine, above the atmosphere, this is an easier argument to make midsummer. You see this in the winter, people aren't as inclined to really, embrace it. But after you've come in, you've come out of your air-conditioned car, or you've, come in from the outside to an air-conditioned building, and you really appreciate that the sun is hot. And that is not how they like to portray the sun. They like to portray the sun as a sort of bit player in their game, in their thermodynamic system. And it doesn't get hot. Even they go to the moon, it's not hot. It's cold actually. And we have Buzz Aldrin looking for his jumper, missing his jumper when he's on the moon because it was cold, because it was nighttime, I think. I don't know why he thought it was cold. He said it was cold in the morning and night. Have you ever thought about that? What that's like in the moon, how it's different from Earth? You know, it's something that an ordinary person can actually comprehend quite easily. So the lunar day is like a month. You get or sort of 2 weeks hot, 2 weeks cold. The lunar cycle. So when you talk about morning on the moon, that's like, I guess, when the sun just comes over the horizon first. But that sun is as strong as when it is right overhead because there's no atmosphere on the moon. The atmosphere is the thing that cools down your morning. The sun has to go obliquely to you from, through the atmosphere, from its source, through an oblique angle. So therefore, encountering every infrared every photon is encountering a lot more resistance, a lot more barriers, peeling off more of its energy before it gets to land. So, in the sun, once you're above the atmosphere, you're on the moon, you're in solstice midday. When you can see the sun, if you can see the whole sun, it doesn't matter what angle it's coming in from. It's midday solstice. It's as hot as it can get. There's no mitigation. There's no atmospheric mitigation like what we have on Earth. We have evenings. We have mornings which are cooler. We have winters which are cooler again. You get none of that on the moon. You're either in the dark, and just to think about it. So imagine the sun's just disappeared below the horizon. You're standing on the moon. The sun's just disappeared. Well, that sun has been blazing down on all those rocks for 2 weeks. So your atmosphere is hot. And this is something that at college and at universities, they have spun a different narrative where you have an absolute zero. As soon as you don't have the sun there, you've got an absolute zero. Never mind the thermal energy that's been captured and stored in all those rocks and all that geology in the lunar surface. They just got people to just negate all that and stop their own cognitive process. People just didn't engage with it anymore because they were baffled by science. And I experienced this as a college pupil. They used to do this to you. We actually all went up to this eminent professor who had an amazing mind for calculation. We said to him, "Isn't it hot up there, in space?" And he said, "Well," and he gives a spiel. It was absolutely bamboozling. And, this is what they do. He said, it depends how you measure heat. It depends how you measure temperature. So if you are talking about the energy in particles, well, there's no particles in space, therefore it's 0 degrees Kelvin. If you're talking about the velocity of particles, well, things fly through space at near light speed, so it would be very, very hot. You've got to understand, this is all completely inappropriate, going nowhere. It's just bamboozling. That's all it is. And astronauts and spaceships have molecules in, and when the sun hits them, That's photonic radiation, if you like. It's infrared radiation. Or you just say it's heat, hitting you at 125 degrees centigrade. That's another thing. They love the centigrade Fahrenheit thing. We use Fahrenheit because of Apollo. We'll always use Fahrenheit as long as as long as men landed on the moon. As soon as men stop landing on the moon, I guess we'll stop using Fahrenheit because we won't need it anymore. If you're doing something that is demanding an extremely accurate thermal measurement, you might find like to have that half degree Celsius unit is very helpful. I can't imagine, a scenario, a cheesemaker. I don't know. I'm sure it's out there, but just say 0.5. Just go the half degree, just go the half decimal, honestly. Uh, so, I mean, there really isn't much else to say about it for definite, absolute proof that they didn't do it because they didn't address the heat. And you talk about other things like the radioactivity and what the crew thought about that. And you had Neil Armstrong famously quipping that we had other things to worry about apart from that. Did you? What, like the heat? No, I didn't worry about the heat. Well, you can't just not worry about it and it goes away. It's there. Your explanations of it are nonsense to anybody who actually is able to think about it. I mean, we've all experienced heat. We know what heat is. Have you heard of the zeroth law of thermodynamics? It states that heat is heat is heat, meaning that whether you're on the moon, on Earth, in a spaceship going in between, or anywhere else, heat follows the same principles, which was set out by Rudolf Claus in 1851, the first law of thermodynamics. Heat basically goes from its source, it goes from warmer bodies to cooler bodies unless acted upon by a force. Basically, a fancy way of just saying, heat is heat. Thermal energy passes from the hottest objects to cooler ones unless you stop it, unless it's stopped doing so by some means. Meaning that the sun heats up everything in front of it, everything it can see, and unless somehow you got around that. And there was never anything in Apollo that would do anything to mitigate the heat that was coming in. They had something called a Wickaway cooling system, which, if you can imagine somebody's trying to keep, an ice cube solid in the sun, and they've got some kind of water drip that manages to, it was only ever designed to protect the machinery, which always worked very hot anyway. All these old time machinery, that was all it was good for. It wasn't for keeping human beings alive, and it certainly wouldn't have done that. And it certainly wouldn't have caused anyone in Apollo 13 to feel awful cold once the cooling system shut down. Well, of course, they never had any cooling system. They never even had a Wickaway in Apollo 13. That's the story that they give us. So, and by the way, I'm not saying that the International Space Station is a joke and it's not real, it's a hoax. But what I will say is that the narrative is very, very carefully controlled to make it, it's like heat is never a problem on the International Space Station if you watch the publications that come out of it and you listen to what's said. But in actual fact, the heat is a big problem on the International Space Station, and anywhere that people try to go above the atmosphere in the sun, the heat's going to be a big problem. So, for example, when they restock the International Space Station, they have to redo the insulation because of the constant bombardment by infrared from the sun. It just the heat that the incoming heat destroys the insulation, and it has to have a do over. They have to, like, I don't know if they chuck the old stuff out. I don't know what they do with it, or they just it just disintegrates into nothing. I don't know. Interesting to find out. You see those huge sort of aga, like an aga cooker, the big lids that you have that go over the top of the hot plate. That's the kind of lids that you have on the windows of the International Space Station. And every time it phases round into the sun, they close those lids by electric motor, and those lids are thick. And I predicted that they would have had those lids before I saw them, um, and then I saw them. Um, so this whole story is a lot deeper. Why just keep this myth up that that men landed on the moon when they didn't? What's the point of it? Well, when you do dig a bit deeper, a narrative starts to develop, which I've told a lot of people about it, and I've published it on YouTube, and I'll state it again quickly what actually happened. So, in 1957, you had Van Allen putting on Explorer 3, which was a suborbital rocket launched by the American Navy. He put a Geiger counter on top of it, excuse me. And he showed that it was very hot up there, with radioactivity. Far too hot for human beings, and we've been frazzled straight away. So that wasn't popular with these guys, the military industrial complex, because they'd set the heart going on the moon. And they wanted to go to the moon because they reckoned they would achieve an unassailable military advantage. So they said to him, there must be some way we can do it. And he kind of tentatively suggested that if the right electromagnetic pulse was brought to bear, then maybe, just maybe, because these electromagnetic pulses, they stop all electromagnetic activity. So you're driving down the road and somebody launches a bomb, and before you've heard anything or seen anything, the electromagnetic pulse is all over you and your car, and your car can no longer work because it's relying on that spark. So it just stops on the motorway and everyone else. And this is a known phenomena of nuclear detonations. So he tentatively suggested, hypothetically, that might work. So they really went at it and tried to make it work. And from 1959 to 1962, they launched thousands of nuclear detonations in the high atmosphere, trying to create the correct electromagnetic pulse, or an effective electromagnetic pulse. Just something that would weaken the magnetism of the planet to a point that they could dissipate the trapped radioactivity. Never got anywhere. It was a complete failure, but they did manage to give leukemia cancer to about 10,500 American kids. And, just look at the global cancer rates, and you can see a very distinct signal from the time that the American government instituted this program of let's go to the moon based pseudoscience. A very sad chapter in our history. Not one that anybody wants to admit to, But there you are. Doesn't change the facts. That's what happened. I've not heard anybody else saying it, but that is evidently what happened. Just look at the facts, check the facts for yourself. So, there is no motivation on record for doing those stratospheric tests. So while they were doing it, what was the object? What was a stated military object? There wasn't one. You know, it's just even the yeah, I have this family, of this uncle, and he's just very practical people, and they're quite on board with anything Joe Stalin might want to do to the population, you know, and but they can't figure it out. Why? Why do the stratospheric bomb tests? It's not like we don't know what nuclear bombs do. What they're testing and what they were testing is they were testing things like the radio signal between points on either side of the blast. What did it do to the radio signal? You know, it's just for what they did find out. I mean, they didn't find out anything as far as I'm aware. In terms of radio signals and nuclear blasts. So, why has nobody asked the questions? Why are they doing it? Well, why would they? They just get shut down. They know why they obviously the powers that be know what happened. And you go high enough up the food chain, you get to the elite at the top. But you must have like a strata of people all the way up who have just thought about it and they've realised what's happened. Aye. So that's why we need to talk about Apollo. Well, the reason we need to talk about Apollo is because I know that you think, okay, let's just leave that in a drawer and that'll be fine. And I can understand that. But here's the problem. You're basing like lots of stuff based on false information. Now, to give you specific examples, I mean, off the top of my head, we're using Fahrenheit instead of Celsius is one, I would say. But, and it's just complicated things and just, like go decimal, US. Please go decimal. What the hell are you doing with your bloody fractions of inches? Never mind that. What else? Well, I did stop one of those Mars explorers because there was confusion, mistranslation between the decimal system and the imperial system. And so that's just one tiny example. But what I'm saying is that the further we go ahead into the future, the greater these little misrepresentations of reality will expand and cause bottlenecks and disasters. And it's just basically a big drag. I guess that, once you admit it, everything falls apart and the whole, I don't really think it is. But China's perpetuating a lot of the American myths. So I always look to China as a great hope and inspiration because of the technological innovation that they are willing to bring to bear in a way that was just not encouraged beforehand. So obviously the internal combustion engine. At the moment, we have a situation where people are paying a premium in order to poison themselves, and they'll continue to support a lumbering coal industry that is more expensive than alternative energy generation and storage because they like the coal industry for some reason. I don't know. I don't know why, but they are subsidizing coal over renewables which a lot of your council's probably doing that. Um, so there are the odd good project uh, happening in the UK. Scotland is one of the best in the world. The UK is one of the best in the world. We're still subsidising fossil fuels though, because it's politically expedient, apparently, although it's also politically toxic. It's oligarchic. It's an oligarch fuel, and the whole Apollo myth thing. I suspect it's yes, well, it is oligarch, isn't it? Because it's the military industrial complex elites who are perpetuating it through the CIA. You know, they're constantly editing the media to clip out the anti-Apollo. I call it the pro-Daedalus and the anti-Daedalus um, sources. So, you know, that's Icarus's dad, and he said to Icarus, don't go too near the sun. And as a nod to that, the crew of Apollo 11 have a little badge stitched onto their beautiful uniforms. And Icarus is one of the badges that you'll see there. And that is a typical CIA sort of double bluff, you know, where they look at the truth in the face, the undeniable facts, and just present them as undeniable facts, but things put round the other way. You get the orders slightly mixed up. I guess something like that. You know, other people are going to put that much better than me. But yeah, so we've all been buying it hook, line, and sinker. So as long as I've overrun on this, I would just like to explain how I came to this position and why I started this inquiry. And, you know, because it's obvious how I reached the conclusions that I have reached, but just for the record, it's not because of a political affiliation or anything. It's just a scientific curiosity, really. And it all started with photography. So I was working in a village grocer's and I was having to buy in film. And so I had an interest in it. I wasn't just working in it, I had an interest in it, although I never actually had a financial share. I was married into it. Okay, so under common law, for the record. So we had to buy this film, and the film is expensive, and the return on it is a bit like dependent on various factors. Crucially, there's a window of expiration on the film, so a sell by date that everybody's always clocking when they go to get the film. And so you're wondering what's. I didn't know anything about photography much. Is there any way that you think I can make this last? I can store it better than what we're doing? And it turns out, no, not really. It's the cause of the degradation of the film is cosmic rays, which are weak gamma and X-rays that are flying in from the sun or the cosmic void or the intergalactic space or whatever, and they're going right through everything and not really bothering anything apart from your film. So you can't really shield against it. You would need like meters of lead shielding to preserve film. It's just facts that I was learning about, and then it transpired that the further up you are in the atmosphere, like, well, even climbing a mountain, you can increase your exposure to cosmic rays by a considerable amount. So here's a fun fact, related to this, because this interaction between the atmosphere and radioactivity is just as crucial, and it's a very close kind of analog. It's practically the same thing as the solar radiation, you know, the heat coming in. So the radioactivity is, where does it come from? You know, it's primarily in these belts, but I think it's obvious that it comes from the solar wind. You know, and you'll get flares, and they'll brush by planet Earth, and we have these magnetic fields around us. And if you look at any lump of metal, its magnet, or any magnet, you'll find that it's got fields around it, and you can trace them out using a compass. And somebody in my college, some young lad, was the first one to discover that if you lifted the compass above the magnet, it would change direction, not once, but a couple of times. And so you can just kind of guess that if your magnet is sensitive enough, you could see three changes of polarity. And I say that because I guess some of you are already thinking it. It's the Van Allen radiation belt became the Van Allen radiation belts. And then they discovered a third belt. And it's exactly the same thing. Your magnetic field changes polarity as you go out from the center. Three times that's detectable. Probably keeps doing it, and we just haven't got the sensitive enough equipment to. Anyway, and maybe it just dissipates after it. I don't know. Whatever the case, the radioactivity is always there, and it's always penetrating to some extent the atmosphere. And the more atmosphere you have above you, the less exposure you have. So yeah, so the point that I was going to make was that when you talk about the shape of planet Earth, everybody knows the Earth is round like a ball. But if you speak to somebody who's conversant in the scientific literature, also known as a nerd, they'll readily tell you it's not actually a ball, it's more of an oblative spheroid, which isn't true. It's as round as a championship billiard ball. However, in my opinion, the ablative spheroid take, which is partially true because the Earth is wider at the equatorial diameter than it is at the polar diameter. That is only put out there because it fits into a narrative that is being pushed. And the point is that the difference between the polar and equatorial diameters of planet Earth, they're practically the same. The difference is so small, it's negligible. Even if it was a championship billiard ball, by proportion, scaled down, uh, it would be allowed. That would be within the tolerance. It's like 20 kilometers over the span of 8,000 kilometers. So, it's 1% is 80 kilometers, would be 1%, and so it would be a quarter of a percent. Apparently, that's okay. Maybe it's not. Maybe I got that wrong. But you can see that the Earth is a sphere to all, intents and purposes. It's a sphere. But it is a sphere much more than the atmosphere is a sphere. The atmosphere is an ablative spheroid. And they never mention that when they're telling you that the Earth is an ablative spheroid, meaning the solid Earth. So it's just a little factoid there that it's just being pushed. It's what do you call it? It's part of the supported narrative. I'm not using my words very well there. But I hope you can understand that it's the fact that they miss the shape of the atmosphere when they're describing the shape of the planet is very telling. And why is it important? Well, I mean, I don't want to ramble too much about it, but there's a lot more protection from cosmic rays where the atmosphere is thicker. So that's why, for example, if you're a pilot on a spacecraft, you're allowed so many polar flights, not very many, but you're allowed as many equatorial flights as you want, where the atmosphere is thick, fine. But don't go over the poles because you're getting exposed. So the International Space Station, for example, you're getting very exposed. And these people are coming back in a terrible state after being there for quite some time, and they've got bone degradation and osteoporosis, and they're weak, and it's all getting put down to gravity. It's nothing to do with gravity. You know, in actual fact, you do feel weightless when you're in the International Space Station, but at the altitude of the International Space Station, if you were standing still, your gravity would be almost the same as what it is if you're standing on planet Earth. And on that point, for example, if you were standing on the pole, you would weigh like you'd weigh a bit less, a bit more than if you were standing on the equator, because in the equator the centrifugal force is pulling you up, whereas on the pole you're kind of just spinning round, and you don't have that centrifugal force making you lighter. So anyway, the point I was making was how I got into this inquiry in the first place. And I was working in this village store, and we were trying to find out how the the film, how to store it and how to make a bit more money by making it last a bit longer, whatever, and why it's getting degraded, and so it becomes obvious that the people in the International Space Station are getting exposed to a lot more radiation, and they are only 35 miles up. The atmosphere is about 70 miles, so they still got about 35 miles of protection, although it's not as good as protection as the stuff that's below them. It's still a bit of mitigation at 35 miles of disassociated molecular soup. That's what they call it, but it's still something. But the radioactivity is penetrating that, the same as the heat is penetrating that, which is the point I was trying to make earlier. That basically, they're not the same thing. They work a bit differently, but they are parallel concepts in terms of how they get to you and how you stop them getting to you, how you protect yourself from that radiation. So they're both radiation. Infrared radiation, ionic radiation. Anyway, so because we're trying so hard to maintain a false narrative, we keep on having to make fudges and put plasters on things where, as we go forward and new stuff gets added to the overall massive data, the elastic band has to the band-aid has to stretch beyond its Young's modulus of elasticity. So we put it like that, and it just means that the truth will out, basically, and this can happen in a catastrophic way, or you can have it in a more gradualist way, which is going to be better for everybody. So maybe just have a think about what I've been saying here, and maybe have a chat in the comments and tell me what you think. And yeah, I'm sure everything's going to work out for the best. I'm an optimist, but it would be nice to talk to people who are, not happy at being told fibs all the time, and they're a bit concerned about what it means for the future and how things are going to roll out. Thanks everyone for listening. If you made it to the end of this, you're an absolute listener, and I absolutely salute you for that. So, yeah, let's talk. Bye for now.